this video, we're going to introduce Section 8 on addition reactions of alkenes, specifically 8.1 on the introduction to addition reactions. So in an addition reaction, two groups are added across a double bond. So in this process, the pi bond of the alkene is lost or it's broken. So as you can see in this generic example, we start with an alkene, and what we are adding is going to add, part of that will add to one of the carbons of that original double bond, and the other part will add to the other carbon of that double bond. Now there are many different addition reactions that we can carry out with alkenes and alkynes for that matter. And so these are very important when we're carrying out synthesis. They allow us to transform from the alkene to various functional groups. So you can see in table 8.1 some of the common types of addition reactions, specifically the ones that we'll cover. So we're going to cover hydrohalogenation, in which we're adding across the double bond a hydrogen and some halogen. So in doing so, we're forming a alkyl halide. We'll also look at the water, different ways we can add water across the double bond. We refer to this as hydration, and the net result is we go from an alkane to an alcohol. We also have hydrogenation, in which we're adding hydrogen, H2, across the double bond. And so that gives us an alkane. And finally, we'll look at halogenation, in which we're adding some halogen, typically bromine or chlorine, to give us a dihalide. So these are the different examples of addition reactions that we'll be looking at in this section. Now the versatility of alkenes is really due to the reactivity of the pi bond. And we've mentioned previously that pi bonds can act as nucleophiles or bases depending on what is available to react with them. And so you can see in this first example, if the alkene is acting like a base, it's going to be donating the electrons in that pi bond, those pi electrons, donating those electrons to the formation of a new bond with the proton from that particular acid donor. And so the acid is acting like a proton donor, the alkene is acting as a proton acceptor. And so the net result in that first step, in this proton transfer, is the formation of a carbocation. As a nucleophile, you can see that what we need present is a good electrophile. And so again, the electrons in this pi bond, the pi electrons, can serve as the new electrons in a covalent bond to this electrophile, giving you yet again another intermediate, the carbocation intermediate. In many cases, an addition reaction is simply the reverse of an elimination reaction. You'll recall in section 7 that starting with an alkyl halide, usually in the presence of a base, we can undergo an elimination reaction to give us the alkene as our product. And so addition reactions can take that same alkene, and we can, in this case, if we were to add a hydrogen halide, we can get back to that alkyl halide in a similar fashion. Now we see that these two reactions, both elimination and addition, in some cases there can be an equilibrium established between these two potential states, that is the alkene as your product or the alkyl halide. What we observe experimentally is that addition reactions are often favored at lower temperatures, while elimination reactions are favored at higher temperatures. And we saw that somewhat, that temperature dependence in the previous section, that when we had a tertiary alkyl halide reacting with water or an alcohol, that at higher temperatures the elimination reaction was favored. And so we see a similar correlation with temperature for addition reactions, that at higher temperatures we see the, if you will, the addition product reverting back to the alkene, but at low temperatures we favor addition. So if you have any general questions about addition reactions, by all means, send me an email. In the next few sections, we're going to look at those specific addition reactions in more detail. Thank you.